Well, hello and welcome, everybody. I'm glad you're here. I've got a really cool high school level geometry question that I thought we could do together. Hang out, do a little math, have some fun. Here are the details. We've got three quadrilaterals. They're all squares, size 4. Middle one's got a side length of 6. And the last one, well, its side lengths are 10. Now, for this diagram, the bottom left hand corner to the top right hand corner is connected by a line segment, and the part of that line segment that crosses the square that's the side length of 6, we're going to call AB, and our job is to figure out the length of that segment. So what is the exact length of segment A to B? So if you'd like to try it on your own, go ahead and pause the video. Do so now. I'm going to share with you here in just a moment my game plan and then tackle it myself, and that will ruin all the fun for you. So go ahead and pause it now because here we go. All right, so my game plan is this. I'm going to tackle this with similar triangles because corresponding parts of similar triangles are proportional. So if you set up a ratio of corresponding parts, they're equal, and that allows you to find missing information. Here's how that's going to look. If we took the entire diagram and connected Q to S, as you see on the screen, and made this triangle, we could figure out all three of those sides pretty easily because it's a right triangle, right? And we could do the same thing for this triangle right here that uses just the first two squares. We'll call that QTU. They're similar because this angle with the vertex of Q is the same in both of the triangles. The angle with vertex of T is a right triangle, same with R, and that means that these last two angles are also the same. And the same exact thing happens if we just do a really small triangle from the square with side lengths of 4. So we can set up proportions right there, and we can find the hypotenuse of the middle-sized green triangle, and we could subtract the hypotenuse of the smallest triangle from it, and what we'd be left with is that segment that crosses the square with the side lengths of 6. So if you tried it on your own earlier and you got stuck, go ahead and pause the video, try it again, because hopefully this is enough information to get you over the hump. Are you ready? All right, so here's what we're going to do. Let's go ahead and explore that triangle. We know the biggest triangle. We know that the bottom side, the longest leg, is going to be 20. 4 plus 6 plus 10 is 20, and we know that that other leg would be 10, and it's a right triangle. So we could use the Pythagorean theorem to find the hypotenuse. So 20 squared plus 10 squared, well, that's going to be 500. Right? 400 plus 100 is 500. Take the square root of both sides. We're going to simplify that because 100 is a square number. The square root of 100 is 10. So 10 root 5, that is the hypotenuse. So we don't really have to concern ourselves with the shorter leg because we're trying to figure out what the hypotenuses are for each of these. So let's use these as our ratios right here. Now let's take a look at our middle-sized triangle. We know that its longest leg is 10 because 4 and 6 is 10. So let's go ahead and clean this up. Set up our proportions right here because the ratio of corresponding parts are proportional. Since we're looking for the hypotenuse, that's what we don't know. Let's put that in the numerator and the long leg in the denominator. And let's go ahead and set those equal. So our big triangle, 10 root 5 over 20, is going to be equal to the hypotenuse over 10. Now, the big triangle's twice as big. The small one's half as large, so all we got to do is take that hypotenuse, 10 root 5, divide by 2. There we go. So 5 root 5 is the distance, the length of that middle-sized triangle. All right, so now let's do the same thing for the smallest one. It's a good idea to always use the thing you know first instead of something you just discovered. So let's go ahead and use the 10 root 5 over 20. And set that equal to the hypotenuse divided by the long leg of this last triangle. Now, this one is 5 times as large because 4 times 5 is 20. So if we divided 10 by 5, we would get 2 root 5 is the length of the hypotenuse of this smallest triangle. All right, so let's take a look at how this fits together in context with our original problem. This green triangle right here is from here to here, so it's this middle one, and this orange triangle or yellow triangle is from here to here. So we don't really need this largest square side of 10 anymore, so let's go ahead and get rid of it and go ahead and overlay our values. So we know that this distance right here is 5 root 5. We know this distance right here is 2 root 5, and if we subtract those, what we're going to be left with is the segment that crosses the circle with the side length of 6. So let's go ahead and subtract those. 5 root 5 minus 2 root 5, of course, is 3 root 5. So the length from A to B was 3 root 5. Hey, I hope you had a good time doing this one. I thought it was a really cool problem, especially for people that are just learning how to do these kinds of problems. I thought this was very approachable and doable, yet not entirely obvious. So if you liked it, give me a thumbs up, like, subscribe, comment, share. If you had a different solution, I'd really love to hear from you. And until next time, I hope you have a great day.